Good morning, Delta Management, Executive, Industry Leader, ladies and gentlemen. So it's my pleasure to share you the session of the AI era and data center impact today. It would be good that I have microphone here and then I can walk around. Is that okay? Because I'm not the one who always stay, so please bear with me if I just walk through this stage. All right, so I would like to start my slide from this page, right? Today, if I talk about power densities increasing in data center, it's not the new topic anymore, correct? But showing this slide, I just want to address some more thing is that we also see the increasing of the power densities of the data centers is really rapidly changed. So in the past, we talk about the power density in one single rack, like 10 or 15 kilowatt per rack for almost a decade, right? But right now, I think people understand that it's reaching to like 100 kilowatt per racks or almost like 200 kilowatt per racks. But we also see in just next 2 or 3 years, the power density of a data centers per racks gonna be reaching to 1 megawatt per rack. So it's not about the power density anymore, but it's also about how we can design a data center in order to cover the future rapidly change in terms of the power densities. If you look at the GPU roadmap, right, I take some of the market leader like AMD or like NVIDIA nowadays. We are now using GB300, right? People start to adapt the GB300 in a data center where we talk about the power density of 132 kilowatt per racks. And the one next coming to the AI data center gonna be the Vera Rubin, right? When we talk about the Vera Rubin, the power density will change from 132 kilowatt per racks to be 250 kilowatt per racks. It's almost double in just 1 or 2 years. It's that quick, almost similar to changing generation of iPhone now. So above Vera Rubin, we can see as well, the chip, the GPU, going to reach 500 kilowatt per rack and even 800 kilowatt per rack. It just next 3 to 5 years. Designing data center today, it's different from the past where we think about 10 years of a data center can serve the server of 10 or 15 kilowatt, right? But now even within 5 years, the rack density changed more than triples. So how are we going to do that? And the next thing from my table here, the power voltage supplying to the GPU will also change from AC to be DC voltage within these 3 to 5 years. How are we going to design our data center to be that flexible, resilient, to support this kind of change, the era of this AI change? The power architecture we are using nowadays, right, we also see, I will not go in detail of the whole chain of power architecture. However, I just would like to address the efficiency of the traditional data center we are using nowadays from the grid to the chip, right? The total efficiency is roughly about only 80%, where 20% is losses, the power loss, which is the heat or the water we use, right? So if 1 megawatt data center and lost 20% is a peanut, right? But nowadays, just mentioned, we talk about 100 megawatt, 200 megawatt, or even 1 gigawatt data center, right? Let's take 200 megawatt data center, right? The losses is almost equivalent to one of the power consumption of one village. A single percentage improving on the efficiencies is the improving of the power consumption that we can share to the society or to those people. Not only about the electricity, right? Also about the water, where the power loss also need water to relieve those heat out, right? Delta also preparing the solution to support the future where when the new GPU coming to be a DC voltage, right? And then how we can make the existing AC data center to support. So what I am showing here, we call this a sidecar solution where we can change from AC to be 800 volt DC, where we also can improve the efficiency by additional 3%. And we also preparing so-called the AI port, where this one we can keep using the AC infrastructures to support the future 800 volt DC. And with existing cooling technology like the fan wall or like the cloud inside the data hall to be able to support the liquid cooling. So inside this AI pod, as you see, we also implement the so-called liquid to air cooling solution, as well as the DC sidecar solution, so that you still can use the AC voltage to supply for high voltage DC. As well as we also can do the hybrid air and liquid by using the in-row modular CDUs. That if your fan wall cooling capacity not enough, you can take more heat out from the CDU. So this is also the solution that we are preparing for the futures. And then you can reutilize your data center, data hall to cope with those high voltage DCs coming to your rooms. Apart from this solution, right, basically in China, we work with one of the cloud operator on the HVDC solution. However, this HVDC solution, we only having the voltage of 240 volt DC. And we also do a lot of integration on this kind of unit. This product called Panama. The name of Panama is from Panama Canal in South America, where instead of you cruise the ship right across those land, right, you can cut to this canal. So it's similar to this kind of product. We actually simplify and reduce the conversion stage to be only a single unit from medium voltage to be 240 volt DC and supply this power to the server. And by using the Panama, right, we also can adapt the battery to do the backup functions. So this Panama will keep 240 volt DC stable supply to the server, even during the power outage. Why I address this? In the future, when the GPU coming with 800 volt DC, right? The 800 volt DC can only accept the input voltage variation only 20 volt. So you need regulated 800 volt DC to supply to those servers, which means you need a battery backup function from the DC voltage. So this Panama, we also look at the future possibility to change from 240 volt DC to also support plus minus 400 volt DC as well as 800 volt DC as well. The question in the industry nowadays, when we talk about the 800 volt DC, right? I believe no one of us experienced how to operate such the dangerous DC voltage, right? And even I haven't talked about the protection, the circuit breaker, how to operate, or what's the ground fault protection, what's the short circuit protection of this, right? So that's how I think Panama solution nowadays still the most practical way, because with the plus 400 and minus 400, we can keep using the existing power distribution system, the breaker, those kind of things, and we can implement the high impedance ground fault detection, which meet IT system, which meet IEC standard. So this could be one of the new candidate when the GPU coming to a data center requirement. Far futures, right? Where the 800 volt DC fully architecture come, that could be also the integrations from the utilities, the 800 volt, data hall, the battery energy storage. Delta also start to prepare the solution on this. We are not talk about a data center anymore, but we talk about bring your own power to your data center with integrated by using solid state transformers, integrating with the battery energy storage, even integrated with the solid state fuel cells, the hydrogen powers as your campus. By using this infrastructure, right, we can integrate the whole renewable energies, like if you have the wind powers, solar powers, the fuel cell solution, the energy storage solution together on the HVDC bus and then supplying to data halls. That also could resolve the power shortage or the microgrid surge or those things, right? By you have your own power into your data center campus. Apart from that, we also preparing the 800 volt DC AI port with 800 volt DC fan wall solution, 800 volt DC CDU solution as well. But I would say that for next 3 to 5 years, or even after the next 5 years. However, Delta already have this solution today. Just to recap again, the AC power port, we have multiple conversion where we can get less energy comparing to the DC solution. We have higher energy power loss. And 800 volt DC will help to increase the efficiencies. The 800 volt DC would be more complex solution, right? You can have single rack with trillion parameter in just one AI port. And then you can have those prefabricated solution integrated and test in Delta factory before ship out to your customers. And our solution here also compatible with no matter NVIDIA GB300, Rubin, AMD, or the Intel AI. Or in the future, like this morning, we have some conversation with the Equinix, right? More in our region would be on the inference, right? That's gonna be the TPU in the future. It's gonna be their own silicon chip to a data hall in the futures. So this solution also could support those kind of the new requirement, make the flexibility, resiliency in our data center to support the future trends. And then we don't need to change the design that many for today. We integrate the DC voltage solution, liquid cooling, and then fully integrate and test from our factory before delivery this kind of solution to the market. So everything has been verified by Delta design team and also factory before we ship out to customer, and then we can parallelly deploy this one to multiple site and location. So that's my last slide about our solution on the data center infrastructure to support the new and the change of the AI era. Thank you.